sometimes, guys. Okay. So who can tell me what you found for the value of E?
2.718.
2.8.
2.85.
Oh wow, we went super specific.
Anybody go that far?
That's
No,
wrong.
I went
Oh no, it's wrong.
5 in. But I saw that number actually. Oh, I can go longer.
It can go longer, right?
Wait, where'd you?
So this, by definition, is an irrational number, just like the number pi. Okay? So pi is a number that continues infinitely. Okay? 3.14, blah, 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 forever and ever. Kaden can tell 100 digits of pi? Wow. Not today, but that's great. You'll impress somebody someday with that. Okay, and then next you're going to memorize the digits of E. What'd you find about who discovered it? Out about
Euler.
Euler.
Euler, yeah. Bernard.
Oh, also Bernard.
Jacob Bernoulli.
No,
John Napier.
no,
Oh.
it's Leonard.
It was
Euler.
Jacob. Wikipedia says Jacob.
No,
Bernoulli.
he said he first brought up the table, whatever the table.
No,
had.
that was the.
Leonard Euler.
Well, you know,
Why would it be?
So-
It's Euler.
It's good to get you guys excited. I'm glad you got a little bit of spirit.
I'm excited.
But you are both correct.
No, it's Euler.
Okay, there is some discrepancy about who in fact did discover the value of E. Okay, they say Euler was the guy who did it first, but Bernoulli did it too, and they both did it, but they did it completely different ways.
itself is credited to Jacob Bernoulli in 1683.
He created the table.
Okay.
Whatever table we're
Well,
doing.
then it must be
The
true.
table of an appendix of a work on logarithms by John Napier.
Oh, that's where Taz got Napier.
Did you read the story about Euler?
No.
Yeah, he's an
Who's
English
Euler?
sailor.
Did you?
That's what it's named after.
Okay, so the way that it was developed, I think, by Brunelli is by, so he was a guy who worked for the king, so he was a mathematician, right? So back in the day, the king was like, all right, I will loan you guys money, but I'm going to do it for an interest rate. Okay, so they're like, okay, perfect, I'm going to compound your interest annually. And then the king was like, actually, I'm going to do it semi-annually. Nah, let's do it monthly. And it kept getting grittier and grittier. Daily. Which one would you want if you were the king? Daily.
Second.
Or how about like continuously? Like always getting interest.
Like forever.
Second.
Forever.
Like every second?
Always.
Wow.
Yeah. Okay, so that's the idea where this came from.
That's tough.
Okay, and that's how they developed the value of E. Okay, so this equation allows you to find E. So this was Euler. He was studying this equation right here. Okay, did you draw it on your
Yes.
computers? Okay, so did you draw something like see if I can do this. Pretty good. Like that. Ooh, that's pretty accurate, I felt.
I got undefined.
Okay. Yeah, did you notice my hole?
Yes. Yep.
I like
Error.
drew the hole because there was an error there.
Yep.
Can anybody tell me why there's an error there?
Because you.
Why does it Euler not, or why does why did 0 not work?
I don't know.
Because yeah, the
Thou
equation,
shalt
if you
not
put
divide by
a 0 into this denominator, the math god says thou shalt not divide by 0. So you cannot divide, so that's why it's undefined. It's also interesting that this function doesn't curl down and go down low like we've seen with our rational equations. Okay? And that has to do with the exponential piece. Okay? So did you happen to discover the end behavior of this function?
Yeah.
Okay? If you trace this and go very far to the right, so as x approaches infinity, what does the y value
2.7.
approach?
Infinite.
Pretty close. Not exactly, though. It approaches e. The exact value is e. Okay, and if you go in the other direction, as x approaches negative infinity, guess what the y value approaches? Ta-da!
Wow.
So that's how Euler found E. Okay.
Or is it the other guys? You said it was the other.
Brunelli did it doing compound interest. Euler did it this way.
Oh, I didn't know we switched to
Okay.
Okay, so here's the notes that I want you to write down. So this is for 13.3. We're using a base of E. Okay, so we worked on Monday with exponential growth and exponential decay. Can anybody give me the parent function for exponential functions?
Something.
There's an A and a B involved. Oh yeah. Remember we talked about with that question number 3 for the worksheet? Okay, so that's your basic equation. Okay, so A is representing what? What? The y-intercept, or perhaps the initial value, depending on if you're doing it with stuff or if you're graphing it. And what is the B? The growth factor. Okay, so we are specifically going to be looking at e to the x for just this lesson. Okay, so when we narrow this down, what is the a value in this particular equation? It is 1. Okay, it's an invisible value, but it is 1. So it has a y-intercept of 1. What is your growth factor? E. Okay, so your b value, which is your growth value, is e. So e, we just found out, is what? 2.718 ... Okay, so if e is 2.718, are we working with a growth or a decay? Growth. Okay, so every function in this section is going to be a growth because they all have a base of e, or a growth factor of e. Okay, so did you happen to graph e to the x at all? Okay, I'll draw this in your notes. Okay, if we're going to draw e to the x, okay, what do we need to talk about first? When we did all of those translations in the last 2 sections, what was the first thing we talked about? Or what was one of the first things that you drew? The asymptote. Okay, where is my horizontal asymptote for this? 0. Okay, so I have a horizontal asymptote at y equals 0. Okay, so as we translate this function, that asymptote is going to potentially move up and down. Okay, what's my y-intercept? 1. Oops. 1. Okay, so my function is simply going to cross the y value at 1. It's going to start by hovering infinitely close to my asymptote and then growing up and to the right. Okay, so all we're going to do is now we're going to take this and we're going to translate it. Okay, we're going to move it up and down, left and right, potentially change that a value. Everybody got that written down? Check. All right, so I'm going to scroll down to the very bottom, use a problem off the assignments. Well, there we go. Not that one, this one. Okay, so let's graph this. Okay, so notice up in the directions, it says, given the function has the form a times e to the x minus h plus k, those variables sound familiar? Okay, so we're doing the same thing that we always do. We're just taking a function and we're moving it around. Okay, so let's identify the pieces for this particular equation. Tell me what the plus 2 at the back of any function does. Ooh, okay, yes. What direction does it move the entire function? Up 2. Okay, so good. So this moves it up 2, and specifically when working with an exponential piece, it moves our horizontal asymptote up 2. So what would be the equation for that horizontal asymptote? Good. Y equals 2. Okay. Up in the exponent, it has a -1. So what direction is that going to move us? To the right. So this is going to the right 1. Okay, now there's this invisible number that we need to talk about. What is that number I'm referring to? The A, which tells us what? The y-intercept. So what's my y-intercept for this one?
1.
Good. All right, so now I should have all the information I need. What's the first thing I need to draw? The old horizontal asymptote. Okay, so I'm going to take that sucker, I'm going to move it up 2. Draw it as a dotted line. Okay. So now for my reference point, I'm going to use what to start it? The A value. Okay. So I'm going to start with my y-intercept at 1. So I'm starting right here at 1. And I have 2 movements. It's going to go up 2 and to the right 1. So from here, if I go up 2 and to the right 1, what is the ordered pair that I land at?
1.
1 what?
3.
1, 3. Yeah, up 2. Up 2? So from here, up 2, 1, 2, to the right 1. Okay, so once I have that point, I'm going to start infinitely close to my horizontal asymptote. Oops, I totally missed. And go up and to the right. What do you guys think? Shall I do another? Pretty easy? Okay, that's all you need to know for this lesson.
Well, then let's do the lesson.
Let's do the lesson.